Welcome back. All right, so by now, hopefully, you have practiced with sine and cosine, and we're going to delve into the wonderful land of tangent. So as we mentioned in the last video notes, tangent has a period of pi, and it doesn't have an amplitude, so we just put DNE for does not exist. And you'll see when we graph it that it doesn't exist because there isn't a maximum or a minimum value for us to find half the distance between, okay? Or we can't find the midline and put half the distance from the midline to the max or the min, so that's why. Okay, so here we go. Our x-axis is going to have the exact same labeling with one little difference. And we are going to go to 0, but I'm going to throw in pi over 4. And then we'll do pi over 2. And then we'll do 3 pi over 4. And then we'll do pi. And here's why. What is, actually, do I want to do the negative with you? Yeah, we probably should. Okay, sorry, erase. Hopefully my pen users aren't using pen, and Devin has his whiteout. Okay, so negative pi over 4, you're welcome, Devin. Pi over 4, pi over 2. Oh, you guys are going to hate me again. Sorry. I'm trying to get one period for you and make it the easiest. Let's do negative pi over 2, final answer. Negative pi over 4, 0, pi over 4, and then pi over 2. Okay, here's why. What is the tangent of 0? Sine over cosine. It is 0. What's the tangent of pi over 4? 1. What's the tangent of negative pi over 4? Negative 1. And then what's the tangent of pi over 2? Okay, so pi over 2, sine over cosine, that's 1 over 0. That's undefined. How in the heck, what do we do if it's undefined? Yes, it is an asymptote. It is an undefined vertical asymptote. How exciting is that? So at negative pi over 2, we are down on the bottom of the y-axis, so it is negative 1 over 0, which again becomes undefined. We have a vertical asymptote. You're welcome. I am so excited as well. Okay, so we definitely need to go negative pi over 2, pi over 2. We could label it with pi over 4s, but we'll leave it at this for right now. 3 pi over 2, and then 2 pi. Okay, so at negative pi over 2, we have a vertical asymptote. Remember, you can't cross those. It is not allowed. And then at pi over 2, and then at 3 pi over 2. Good. And we have a coordinate at 0, 0. At pi over 4, it is 1. At negative pi over 4, it is negative 1. And that pattern continues. Okay, so then we curve it up. Ladies and gentlemen, I'd like for you to meet your tangent function. It looks so cool. Remember, we get really close to the vertical asymptotes. We don't touch it. Your graph has to curve, okay, because of the values if we were to find them in between those tiny little pieces, okay? So we start down at the vertical asymptote, we curve through the 3 points that we have, and we curve up. Very nice. Okay, domain and range are a little bit, well, range isn't tricky, but domain's a little bit trickier because we say, well, yeah, it exists everywhere, except it does not exist where there are asymptotes. So notice, we have one asymptote at pi over 2, one asymptote at 3 pi over 2. They are separated by pi units, which is the period. Okay, so we're going to say x cannot equal the location of an asymptote plus the period k, because it occurs every pi intervals. So we have to account for the fact that this function it's non-restricted. It goes on forever, right? So we're going to say pi k where k is any integer. And this will account for the infinite amount of asymptotes that lie on this function. You can't sit there, even though I'm sure you want to, and list them all out. Okay, so again, location of an asymptote plus the period k, where k is any integer. You have to define k, otherwise it doesn't count. And then the range is all real numbers. Beautiful. All right, let's transform it. Let's do it. Page 5? Nope, page 6. Here we go. Okay, so just like with sine and cosine and every other function we've done, you have to factor out the b value if it exists. Okay, so we have 2 tan, factor out the 3. Theta is just our input. You can use x if you want to. So the 2 means that we're going to have a vertical stretch. It is not the amplitude. It is not the amplitude. We do not have an amplitude because we do not have maximum or minimum values. Okay, and the 3 means that we're going to have a horizontal compression, but no horizontal or vertical shifting. Okay, so for the parent function points, we're going to use negative pi over 2. That's our first asymptote. Negative pi over 4, 0, pi over 4, and then pi over 2. These are asymptotes. Tangent of negative pi over 4 is negative 1, tangent of 0 is 0, and tangent of pi over 4 is 1. Those of you that have mastered the unit circle, I'm sure right now are so happy, and you're welcome. I told you. Okay, so then the b value will be 1/3 because we take the reciprocal times x or theta. It's the input, it doesn't matter, and then 2 times y. Okay, so if we plug in negative pi over 2, we get negative pi over 6. Plug in negative pi over 4, we get negative pi over 12. Plug in 0, you get 0. And then we get pi over 12 and pi over 6. For the y values, plug in 2. Well, don't plug in 2. Plug in an asymptote, you get an asymptote. Plug in a negative 1, you get negative 2. 0 is 0, 1 is 2. The asymptote stays the same. Okay, for the period is pi over the absolute value of b. Remember, it's a shorter, if you look at the functions, tangent's a lot shorter for it to repeat versus cosine takes that length and sine takes that length. Okay, so it's half of it for it to repeat. So that's why it's pi. So pi over the absolute value of b. Our b in this case is 3. So this is just pi over 3. All right, let's write it out. Okay, so for our x-axis, I'm still going to go out to 4 tick marks. That's what we've been doing. That's what we're used to. Why change it now? So I'm going to go out to 1, 2, 3, 4 tick marks, and this is pi over 3. Well, what's half of pi over 3? Pi over 6. What's half of pi over 6? Pi over 12. So every tick mark is increasing by pi over 12 units. So pi over 12, 2 pi over 12, 3 pi over 12, or pi over 4, 4 pi over 12, 5 pi over 12, 6 pi over 12, 7 pi over 12, and so forth. I really am only going to need you to label out 2 periods for tangent, okay? Do as many as you want, absolutely, as thorough as you want to be, but know that I'm only going to expect that. Okay, and then we'll go up to 2 and down to negative 2. Excellent. All right, here we go. Let's graph it. So at negative pi over 6, I have an asymptote. And then at pi over 6, we have another asymptote. 0, 0, pi over 12 is up at 2, negative pi over 12 is down at negative 2. So notice that here's my first asymptote, 1, 2, 3, 4 tick marks. So I'm going to go 1, 2, 3, 4 tick marks to find another asymptote. And then negative 2, 0, and 2. Connect them through a beautiful curve, please. Oh, come back. There we go. And there it is. Yay! So the domain is all real numbers. X can't equal the location of the first asymptote. You could put negative pi over 6. It doesn't really matter. It's just a location of an asymptote plus the period k, where k is any integer, because it's going to occur every 4 tick marks. It takes 4 tick marks to cycle through a period. And then the range is all real numbers. or ta-da! Nice. Let's go to the next one. Okay, that was example number 1. Example number 2. Now, keep in mind, if there's a b value, you have to factor it out. Okay, so we have y is equal to the tangent of pi over 3 times theta. Theta is your input. That's a funky looking theta. Change it to x if you don't like it, or just erase your theta and do it again if you don't like it. There we go. All right, we only have one transformation. A is 1, h is 0, k is 0. Since tangent is pi over 3, okay, well, we don't know what that is, so I'm going to put it into my calculator to see what that value is. You know what? I'm going to try really hard to do it right in my calculator. Okay, so it's approximately 1.05, which to me thinks that it's going to be a compression. If I were to test my theory, I would be right, because it is approximately 0.95 as a reciprocal. So we're going to say that this is a horizontal compression. Yeah, if we give you some b value like that and you're not comfortable with converting it, use your calculator. That's totally fine. Okay, parent function points. Here we go. X and y. We have an asymptote at negative pi over 2. At negative pi over 4, tangent is 1. At 0, tangent is 0. At pi over 4, tangent is 1. And then at pi over 2, tangent has another asymptote. The only transformation that we're going to see is 3 over pi times our x value. The y's will stay the same. So if I take 3 over pi and I times it by negative pi over 2, we end up with a negative 3 halves. Okay, again, the pi value disappears. Don't be afraid. It's totally okay. If we plug in, I'm writing it out for you, negative pi over 4. Okay, you get negative 3/4. The y value is still 1. 0 is 0. Y value is still 0. If you plug in pi over 4, you end up with 3 over 4. The y value is 1. Pi over 2 is going to be 3 halves. The y value is an asymptote. Amplitude, 1. Nah, it doesn't exist. How many of you were like, yeah, it's 1. No. There isn't a maximum or a minimum value. So there can't be an amplitude, okay? The period is pi over the absolute value. So our period is 3. Again, for those of you that want to see it, it's pi divided by pi over 3. So pi times 3 over pi gives us 3. All right, let's label it out. I'm going to go 4 tick marks out. Label it 3. What's half of 3? 3 halves. Half of 3 halves is 3/4. So it's 3/4, 6/4, 9/4, 12/4. Say that 5 times fast. I don't want to. Okay, and we go, it looks like, oh, hello, Patterson. You did something wrong. I forgot the negative. Sorry, guys. If you caught that as we were writing it down, I appreciate that. There we go. Okay, so at negative 3 halves, we have an asymptote. At negative 3/4, it is negative 1, 0, 0, 3/4, 1, and then we have another asymptote. Now, if you'd like, you can extend it out so that you can get the other asymptote, or you can just draw a portion of the tangent function. I'm okay with either one, to be honest. There we go. And that will encompass 2 periods. Oh, I love the tangent graph. Some of you may be asking about the midline. The midline still goes through the middle of the graph. It's not as important. Sorry, it's important, but it's not as crucial that we understand where the midline is for tangent functions, because we're cutting through it, whereas sine and cosine, we're bouncing back and forth from it, so that way it has a little bit more validity for sure. Our domain is going to be negative infinity to positive infinity. X cannot be the location of an asymptote, so I'll pick 3 halves plus the period, k. Period is 3, where k is any integer. Any integer. And our range is all real numbers. Nice. All right, 2 more examples, you guys. Write a tangent equation that has the following characteristics. So we did this with sine and cosine. Sorry, my chair is so squeaky. The period. Okay, so the period is normally pi over b, but we're told that it's 2 pi over 3. If you can't see what it is, just by looking at this proportion, cross multiply. So we get 3 pi is equal to 2 pi times b. B is 3 pi over 2 pi, which means that it's 3/2. Okay, we have a vertical compression. Notice it doesn't say amplitude because we can't have an amplitude. So that means that A is going to be 1/2. B is 3/2. And then we have a vertical asymptote at pi over 6. Okay, go back to the original parent function. Our first asymptote is at pi over 2, and it was 2 tick marks out. Okay, 2 tick marks out. If you need to, write that down so you can remember. The first asymptote is 2 tick marks. Okay, so if our period is 2 pi, right here, okay, 2 pi over 3, and I were to go 4 tick marks, here's 2 pi over 3. Cut that in half. You get pi over 3. Cut that in half. You get pi over 6. So our first asymptote doesn't occur 2 tick marks out. Our first asymptote occurs 1 tick mark out. So we need to go, this implies that we need to go left pi over 6 units. And I say left because we're now 1 tick mark out, and every tick mark is pi over 6. Hopefully you're with me on that one. If not, I'm sure I'll get questions. You know I love those. So y is equal to our a value times the tangent of our b value. Okay, and then minus, whoa, that's a big fail. We need to go left. So we're going to say plus pi over 6, because that is our h value. So a little bit more thinking involved in that one, because it's tangent and we have asymptotes, and it's not, I feel it's just a little bit trickier. Okay, take your time, guys. Write everything out. Last but not least, write a tangent equation for the graph below. Alrighty. Looking at this, couple things, it looks like we've got we start here, 1, 2, 3, 4 tick marks. Okay, so smack dab in the middle is the center. So I would say that h, well, we definitely went, instead of being 2 tick marks out, we went left. Okay, so h is going to be left pi over 12 units. K, we went up 1. Oh, just kidding. We went up 2. I'm thinking of our 1 point. Let's see. If it's pi over 12 units, well, we've got pi over 12, 2 pi over 12, 3 pi over 4, 4 pi over 12. So the period is 4 pi over 12, which reduces to pi over 3. Okay, so then if it's pi over b is equal to pi over 3, that means that b is 3. Okay, all of this is process of elimination. However you want to attack it is totally up to you. Okay, and then we have to figure out, we've got b, a. We don't have our a value yet. That's the last thing. There isn't a reflection because it looks like it still goes down to up, so we're good with that. Let me erase some of this extra stuff. But we do need to figure out if there was an a value shift or not. Okay, so if we're here and we go over 1 tick mark and we're here, does it look as if we go up 1 unit still? And the answer is yes. So the a value is 1. Let's put these into an equation. We get y is equal to the tangent of b is 3. We're going to go left pi over 2 units, so x plus pi over 2, and then we go up 2, and we are done. Whoo! Remember, write it all out. Take your time.